This video uses C# principles such as binary serialization. The link to this webpage will be found in the description below. Binary serialization is the creation of data into binary format, but from things that we can read ourselves, such as integer strings and floats. For this video we are going to format floats and strings to create our game object again from a saved file. We cannot actually save game objects, and we cannot save vectors or quaternions in the standard way that you would want to in Unity, but I do have a workaround for this. When the data is serialized, it will go from your standard ID string, such as cube, into a set of zeros and ones in the file. This means that this file cannot really be tampered with to mess with save files, and should be pretty easy to keep secure. So for this tutorial we're going to be using a setup scene that I have made that will generate 50 random objects in different places. So there are 3 different random objects they can have. So what we need to do is save which object it is, its position, and also its rotation, as in most cases when you're saving your objects you are going to want to save rotation. So I'm definitely going to implement that into our save load system. So if I press R, we get another completely random setup of different cubes. So the plan today is to use this sample to teach how to save different game objects. So you cannot just save the game object as a whole, as Unity game objects are not serializable. We will get on to that serializable word in a bit if you do not already know what it is, but to start this tutorial we are going to need a couple of extra classes. So outside of the random placer or your object placer class, you're going to want to create a new class, a public class, call it something like saveable objects. So that's our first new class. We're also going to want second, which is going to be another class, and I'm going to call it identification. So both of these classes are going to need to be serialized, so we're going to give system.serializable as a over the top parameter on both of them. So in the saveable objects we're going to need a string, which is going to be our ID. The ID is going to be the thing that we're going to use when we are recreating the objects, so that needs to be saved. We're going to save a couple of different floats, so we're going to save px, py, and pz. Now this is going to be the position, so position of x, y, and z. The reason we can't just save position is it is also not serializable, so we're going to use different float values and reconstruct the position from that. We're also going to save another set of floats, which is going to be our rotation, so Rx, Ry, Rz, and Rw. The W is part of the quaternion, and I would definitely not advise, unless you are very good knowing with quaternions, messing about with that value. That is just a value we need as an extra. It is not shown in the inspector. See, as you can see here, rotation X, Y, and Z. We do not have the W value showable, but it does need to be saved, so we're going to keep that on there. We're going to add another constructor, so public saveable objects, and we're going to take in a string, which is going to be our ID. We're then going to take a vector 3, which is our position. We're also going to take a quaternion, which is going to be our rotation. So we're now going to do this.id equals the ID that is passed in from the constructor. So that is going to be passed over to here, so that ID is now whatever we pass in here. Our px equals the position dot x, our p. We're going to add another function into our class, which is going to be a vector3 function, so a public vector3 called return position. And in here we're going to just create a vector3, so vector3 pos equals px equals new vector3 px, py and pz. We're then going to use the return keyword and return pos. That just means that when we do this dot return position, it's going to give us the full position instead of having to create the vector using these variables. So we're then going to do the same for the rotation, so a public quaternion return rotation, and then we're going to create a quaternion value of rot equals new quaternion rx, ry, rz and rw. Now it is vitally important that you do not get these the wrong way around, so it's going to go x, y, z, w, and for position x, y, z. You cannot get them the wrong way around, as it will not return the proper rotation or position of that object. So we now have these variables set up. So what we're now going to do is create a couple of lists. So we're going to create a public list. Now you are going to need to use, so add the using tag of system.collections.generic at the top, and that gives you the list. So we're going to create a list of savable objects, call them savable objects, equals new list savable objects. There we go. We're going to create another list. Actually, no we're not. We're going to change something over slightly. So up here we're going to change this to a array of identification called placeable objects. Now at this point we're going to add some variables into here. So we're going to need another ID string, but this part isn't saved, so we can add a game object, which is going to be the prefab for our object. This is just going to link the ID with the prefab, so that when we're reinstantiating our variable, our objects, we will be able to get the right one. So using that, we now making sure that they are public. Yeah. So we're just going to add in this bit here, the prefab, and that will fix the code fine. So next we're going to start a new C# script. I'm going to call it save load. I'm going to open that up. So we're going to remove the default part of the script, and we're going to add a couple of using tags. So we're going to be using system.io, so system.input-output. We're also going to be using, this is quite a long one, system.runtime.serialization.formatters.binary. So we are going to be creating our data into binary, so of zeros and ones. So we're now going to create a public void save, and we're going to create a public bool load. Now a public bool, this use of bool is exactly like a void, but at the end we need to return either true or false. So I'm going to put at the bottom of this statement return false. So that is going to be assuming that we have not managed to load the data. If we haven't, then we're going to start creating the random variant of the objects. So in the save part, we're going to need to create something called a file stream. So we're going to, and we'll call that fs equals file dot create application dot persistent data path plus, you're going to put this in quotations, a slash with your then name of your file. So we're going to call ours saveable objects.dat. Now, at the top here, I'm going to put in our list. So the list of savable objects. So savable objects. Now that list is going to be grabbed from here when we are saving, but we need to create our random placer, which is the name of our placement script. And we'll call this random placer equals get component placer. So then we're going to create a void start. Our random placer is going to equal get component random placer. Now the reason we can use the get component part is because I'm going to have my save script also linked with the same script that has my random placer. If not, you are going to want to use random placer, or whatever your script name is, equals find object of type random placer. But in this instance we can use the top one, so I'm going to remove that. So we're going to use this. Now in our save variable we're going to need to create binary formatter, bf equals new binary formatter. So that is going to be the part that actually turns our data into ones and zeros. But before we need to do that, at the very top we are going to get our savable objects from the random placer script. So savable objects, there we go. So that is going to allow us to save the objects that we have got listed here. I'm going to go in to where this actually comes in pretty soon. So now we're going to do bf.serialized. So this is actually making the format of the data binary. So we're creating our ones and zeros in that file. So serialize the file stream fs with the savable objects. Now we are allowed to do this because in our other script we have declared our class as serializable. This is why we're having to use the position and stuff like that in this way. So we then, this is definitely something you've got to make sure you do, we've got to close the file stream. So fs.close brackets at the end. So that is the save part done. So now we're going to go on to loading. So we're going to create a new string called path, which is going to equal application dot persistent data path plus saveable objects.dat. So you've got to make sure that this is the same as that, because otherwise you are going to have some issues. Just remove that bracket there, I don't know why I put that in. So there we go. So now we need to check if that file actually exists. So if the file .exists at path, then we can load it. If it doesn't, then it's going to return false. Now the reason we don't have to use an else statement is because in here, once we've got the stuff, it will return true, and this will not be executed after. So we're now going to do the same thing again. So we need a file stream fs equals file.open at path with file mode dot open. We're then going to do the same with the binary formatter. Binary formatter bf equals new binary formatter. There we go. So we're now going to check to actually make sure that file has more stuff in it. So the file will be created anytime it attempts to load. So what we're going to do is we're going to make sure that file actually has some data in it for us to read. So if the file stream .length is over 0, then we continue. If it doesn't, this will carry on and it will return false, which means we will get the random. So we're going to have our saveable objects is going to equal, now this bit is fairly complicated, so the list of saveable objects bf.deserialize, put the file stream in there, and there we go. So that is going to give us our data back. So then at this we can then make random placer.saveables equals our saveable objects. Now we've loaded it back. Now to continue with this, we need to create a new function in this part. So we're going to create a public void reinstantiate which is then going to allow us to recreate all of the objects. So in here we're going to do a for loop, so int I equals 0, I is going to be saveables objects dot count I plus, then for int z equals 0, z placeable objects dot length z plus. So we need to check if saveable objects dot id equals placeable objects dot id. So this means that the ID from the data is the same as one of the IDs in our identifications. So this now means that we can create our object. So game object equals instantiate placeable objects z.prefab object dot transform dot position equals saveable objects I dot return position and then object dot transform dot rotation equals saveable objects dot return rotation. So we now have all of the instantiation, loading and saving parts. So we now at this point just need to do one last thing. So in our saveable objects we need to, at the bottom here, we're going to do saveable objects.add new saveable objects, and then we're going to put object random pos, and actually in this instance we're going to do object.transform.position and then object.transform.rotation. So I got this bit wrong, so all I actually need to do is get the placeable objects at rand.id. So we send the ID in, the position and the rotation then to the saveable objects field. Now, assuming that I have done everything exactly how I should have done, then that means this should all be fine. This bit. So I'm going to just do random placer.reinstantiate. We're then going to close the file stream. Then we return true, which means not to generate the random stuff. So up here we're going to have to add a new if statement to actually check this. So at the top, we're going to need save and load script, so save load there. So at the top of start, let's just remove this bit. So at the top of start, we're going to save load equals get component save load, but remember you can also use the find object of type. So here you would use equals find object of type save load. If your script is on the same object, then you are going to use this line. If it is not, then you are going to use this line. So we're going to use this one. I'm just going to remove this line here, specifically because it was for the demonstration. I'm going to remove the update void because I don't need it. Now, here we're going to do an if statement. So, if save load dot load equals false, then we do this. Oh, make sure you include that there. So if that returns false and we didn't have any data to load, then we're going to want to run this. But if it's true, then this all happens and this can be ignored. So I'm just going to do one thing, which is object.transform.parent equals parent there, so we can do that. So we should be very close to ready. So after we've done this, we're going to do save load dot save. You can pick how you want to save, whether you save after a certain key press or a button has been pressed, but in this instance we're going to create our objects and then save. So then when we get the first set of objects that are going to come through when we first need to create this. So red cube, green cube, and blue cube, and I am going to create, so blue cube, green cube, red cube there. So I'm going to increase the amount of objects that we're going to place, so I'm going to make that 80. I forgot one very important thing. You are going to want to make sure that your save load script is either on an object in your scene if you're using the find object of type, or on your own object if you are using the get components, and make sure that that has been put on there. We do not need to mess around with that. So when we play, we should then get all these random objects. Now if I exit this now, you will notice that all of these are going to be placed again the exact same. So as you can see, I chose the red one to check, and that is in the same place. All of these are in the same place, so this will now always load. Now if you ever wanted to find out where your data is being stored, you are going to want to go to your Windows and then app data percentage, we're going to press app data, local low, and then it's going to be whatever your company is defined as on Unity. So in this case I'm using default company. Save load tutorial, and then it is in here. Now obviously you cannot read this data, but this is where it is all saved. So if I wanted to get a different type, I could go and delete that file. So now it's different again. If I open it, we're going to get the same thing again. So it'll always be recreating that file if you delete it. So if you delete it again, just to demonstrate one more time, there's the position. So I'm going to watch the blue and the red up here, and let's see if they are in the same position again, and they are. So that is how you do binary serialization, also known as saving and loading in Unity. I hope you did enjoy. Make sure to follow my Twitter for all the updates on tutorials or devlogs, and thank you very much for watching.